At this juncture, let us proceed to the second classification of isomerism, stereoisomerism. In our prior discussion, stereoisomerism is a type of isomerism in which the structures differ due to the differences in spatial orientation of atoms in a molecule. I repeat, when we say stereoisomerism, this exists due to differences in the arrangement of atoms in space. So it has something to do with the three-dimensional arrangement of atoms in a molecule. Now, under stereoisomerism, there are three subtypes. We have the geometric, optical, and conformational stereoisomerism. For this pre-recorded lecture video, I will present to you all about geometric isomerism. When we talk about geometric isomerism, this type of stereoisomerism commonly occurs among alkene. Again, stereoisomerism under geometric isomerism, this commonly occur among compounds with a double bond. So I am referring to alkenes most specifically. Recall that in our prior discussion on structural isomerism, alkenes may show a specific type of structural isomerism, particularly position isomerism. I repeat, in our previous discussion on structural isomerism, alkenes can show position type of isomerism in which structures differ specifically due to the differences in the position of the double bond. Let's say, for example, in the molecular formula C4H8, this could produce 1 butene or A2 butene. Again, we're in this structure. In this structure, they differ in the position due to the differences in the position of the double bond. For the first structure, the double bond is present at carbon 1. For the second structure, the double bond is present at carbon 2. So that is a position isomerism. Particularly or generally, it falls under structural isomerism because the structures uh, ju- uh, exist due to the differences in the order of bonding. Now, alkenes, aside from structural isomerism, they may also show geometric type of isomerism. When we say geometric isomerism, this occurs due to the restriction to rotation on the part of the alkene, which is the rigid part, the carbon to carbon double bond. Again, because this part of alkene, carbon to carbon double bond, because this part here is rigid, it cannot be rotated. Okay? Therefore, when we try to analyze then the three-dimensional orientation of the atoms or the group of atoms that are directly attached to each double bond carbons, okay, in a trigonal planar orientation, they may have a different arrangement. Particularly, it could produce two possible structure for a molecule of alkene. Okay, again, Because this part of the alkene, yung carbon to carbon double bond, it is said to be rigid. Okay, common sense, it is rigid. Okay, it cannot be easily rotated kasi it it is bonded, the two atoms is bonded by a double bond. Okay, isang bond nga lang that is already that already makes the atoms be held together. So kapag dalawa, may multiple bonds na, magiging much more rigid na yung nature ng bonded atoms. Okay? That makes it restricted to rotation. Kaya when we draw its three-dimensional atoms, okay, or three-dimensional arrangement of the group of atoms that is attached to this carbon and the other carbon, pwedeng itong directly attach X na group of atom to the first double bond carbon may be written on top of it, or sa trigonal planar orientation siya, yung itong um, itong group of atoms designated as X sa isang structure nasa baba siya. Okay, so sa first structure, pwedeng yung group of atoms na designated as X nasa taas, or sa second structure niya, nasa baba naman siya. Okay? Then yung letter Y na group of atom attached to the first carbon atom, nasa taas naman for the second structure. Okay? So let's have a specific example, okay, for easy understanding. Let's say, for instance, the alkene is a 2-butene. Okay, but this is 2-butene. You already know how to name. Okay, this is 2-butene. Okay, now again, when you draw the three-dimensional arrangement of the group of atoms attached to the double bond carbons, pwedeng in this first double bond carbon, itong hydrogen nasa baba. Okay, again, in the first double bond carbon, I'm talking about the first double bond carbon, the first carbon carrying the double bond. So that is carbon number 2. The first carbon carrying the double bond, that is carbon number 2. So ito lang yun. Okay? So sa carbon number 2, yung directly attached sa kanya na hydrogen and the other group is in a form of methyl, pwedeng magkaiba yung position niya. Sa unang structure, pwedeng yung methyl group nasa taas, okay, for a trigonal planar orientation ng mismong carbon na to, and yung hydrogen nasa baba. Okay? And then, on the second structure, pwede naman itong methyl group, okay, nasa baba. Then, yung encircled na kulay blue na hydrogen, nasa taas naman. Okay? That is still 2-butene. Tingnan. Okay? Tingnan ngayon yung hydrogen nasa taas na. Yung methyl group, which is the carbon one, okay, here, nasa baba naman. But still, try to check the name of the molecule. This is still 2-butene. Ito lang pa rin yun. Okay? So they have the same they actually have the same molecular formula. Okay? They have the same molecular formula. But look at the three-dimensional arrangement of atoms in space. Okay? Kapag dinraw na natin in a trigonal planar orientation yung mga carbon-to-carbon double bonds, okay, they will now have a different orientation of the group of atoms directly attached to this double bond carbon. So this shows isomerism. Okay, so ito yung tandaan nyo. When we talk about geometric isomerism, a particular alkene compound will show geometric isomerism if again, a particular alkene group will show a geometric isomerism if on the double bond carbons, on each double bond carbons, they will have different group of atoms attached to it. Okay, so kapag tiningnan mo on the double bond carbon, itong double bond carbon, okay, magkaiba yung group of atoms na ka-attach sa kanya. So for this example, merong methyl, yung isa merong hydrogen. So the same with the second double bond carbon, magkaiba din yung group of atoms na naka-attach sa kanya. So yan yung pinaka iput nyo sa mind nyo before before classifying a particular set of structures as showing geometric isomerism. You have to check first if the alkene group on its double bond carbon, each of these double bond carbon will have different group of atoms attached to it. Okay, so diba, dalawa lang naman yung directly attached, no? Directly attached to these double bond carbons. Okay? So kapag magkaiba yung atoms, group of atoms that are directly bonded to each double bond carbon, then it shows geometric isomerism. Okay? Now, another point, when you already classify, so check na, it shows geometric isomerism. Now, after predicting na, okay, it shows geometric isomerism, the second thing that you have to find out is if on the double bond carbons, it has at least one hydrogen atoms each na naka-attach sa mismong double bond carbon, that shows a specific type of geometric isomerism. Okay? And that specific type of geometric isomerism can be regarded as cis or trans geometric isomerism. Again, kapag you already classify that a compound shows isomerism and that general isomerism is a geometric isomerism, then you have to determine the specific type of geometric isomerism. Now, kapag each, I'm talking about each double bond carbons has at least one, no? Have only one hydrogen bonded to each double bond carbon, then that shows a cis or trans geometric isomerism. So in this example, because each double bond carbon has directly attached one hydrogen atom, then it shows a cis trans isomerism. Okay? Now, when do we predict that a structure, that a geometric isomer is a cis isomer? Kailan naman trans isomer? Okay, ito yung tandaan nyo. When the same groups are on the same side, when the same groups are on the same side of the double bond carbon, the geometric isomer is regarded as cis. Okay? Kapag nasa same side yung same group. Okay? So for this example, sa first structure, structure letter A for 2-butene. I want you to check where is the hydrogen group for this highlighted, orange highlighted na carbon. Di ba yung hydrogen nasa baba? For the second double bond carbon, nasaan yung hydrogen? Nasa baba. Yung priority groups na methyl, in this example, priority group ngayon yung methyl group. When you say priority group, that could be any group, okay? Any group of atoms except hydrogen. Okay, so this could be any group of atoms except hydrogen atom. So kapag hindi yan hydrogen directly attached, kapag hindi hydrogen directly attached to the double bond carbon, automatic that is a priority group. So the methyl group are on the same side. The hydrogen group are on the same side. Therefore, this is a cis 2-butene. Okay, this structure shows a cis isomer. Okay, and cis and trans are prefixes, and prefixes are added on the first part of the full name ng alkene. So that makes it cis dash 2-butene. Okay, so this would be the full name of a given alkene compound na 2-butene. It is in a cis orientation. Okay, isa siyang cis isomer. Whereas on the second, tingnan natin yung second structure. Okay, second structure for 2-butene. Okay, I want you to check where is the hydrogen for this double bond carbon. It is on top, no? Okay, what about the hydrogen for the double bond carbon on the right side? It is on the bottom part. Okay, for its trigonal planar orientation, nasa baba naman naka-attach. So obviously in this case, the same groups are on the opposite side. So kapag opposite sides naman yung the same group or priority groups, then that is regarded as trans isomers. Okay? Kapag nasa opposite sides naman. Okay? So this time, this is specifically named as trans butene. Okay? Trans 2-butene. So that is how to identify the cis trans isomerism. Alright? So let's have a short recap. First thing that you have to do to identify if it is geometric, if it shows geometric isomerism, tingnan yung double bond carbon, check nyo agad yung double bond carbon. Okay, double bond carbons. For each double bond carbon, kapag magkaiba yung group of atom, okay, for each double bond carbon, kapag magkaiba yung group of atoms attached to it, directly attached to it, that shows geometric isomerism. Pati yung pangalawa, dapat magkaiba din yung group of atoms nga naka-attach, directly attached sa mismong double bond carbon. So that is, okay, that structure shows geometric isomerism. Now you have to identify the specific type of geometric isomerism. If on that double bond carbon, carbons each has one hydrogen atoms attached to it, then that shows a cis trans isomerism. Okay? Now, kapag ang isang double bond carbon, kapag ang isang double bond carbon, dalawa, okay? Let's say hydrogen din yung naka-attach dito. Okay, hydrogen din yung naka-attach dyan. That does not show cis trans isomerism. Okay? Even geometric isomerism, no? It doesn't show geometric isomerism. Kasi, in this case, these are the same group of atoms attached to the double bond carbon. Dapat, yung criteria natin for geometric isomerism, sa double bond carbon, magkaiba yung directly attached na group of atoms. Okay? And for cis trans, for it to be regarded as cis trans isomers, dapat on each double bond carbon, at least, merong isa lang po. Okay? Isa lang po na hydrogen each double bond carbon. Sige, let's have another example. Okay, for this molecule of alkene, 1 chloro. Okay, 1 chloro propane. Okay, or 1 chloro, not propane. 1 chloro, 1 propene. Again, this molecule of alkane is 1 chloro, 1 propene. Okay, that is 1 chloro, 1 propene. So the same thing, if you try to check the orientation, in the three-dimensional orientation on the central double bond carbons, okay, yung mga directly attached sa kanya na group of atoms, pwedeng may dalawang orientation. Okay? So let's say ito yung carbon 1. Ano ulit yung naka-attach sa carbon 1? Okay? If this is the double bond, ito yung mga naka-attach. If ito yung double bond, ang mga directly naka-attach sa carbon 1, una, hydrogen, pangalawa, chlorine. Okay? Una, hydrogen, pangalawa, chlorine group. Okay? So, pwede ang hydrogen nasa taas, okay, ng carbon 1 or ng double bond carbon, first double bond carbon, yung chlorine naman nasa baba. Or on the second structure, yung hydrogen naman nasa baba na. Okay? Then try to check. Sa second double bond carbon, if magkaiba din yung naka-attached na group of atoms sa kanya. So magkaiba, merong methyl, ang isa hydrogen. Now, this time, we can now predict the specific type of geometric isomerism because each double bond carbon has one hydrogen directly attached to it, then we can predict a cis trans isomerism here. So in the molecule of 1 chloro 1 propene, the first structure shows a trans isomerism. The second structure shows a cis isomerism. Okay, so I hope you already know the rationale why the first structure is a trans. Okay, trans kasi the same groups, okay, the same groups are on the opposite side. Okay, the same group are on the opposite side. So the hydrogen group are on the opposite sides. The priority groups also the same thing, opposite sides. Okay, so yung priority group that directly attached sa first double bond carbon is a chloro group. On the second double bond carbon is a methyl naman, yung priority group. So, magka-opposite sides, so trans. Then, vice versa, tingnan yung attachment ng hydrogen atoms, okay, sa double bond carbon sa second molecule, second structure, same side. Same side, yung same groups, then it shows a cis isomerism. Same side, yung priority groups, cis isomerism. Okay, another example. We have the molecule 2-pentene. Okay, so this is 2-pentene. Okay, so again, analyze nyo kapag uh, dinraw mo yung three-dimensional trigonal planar orientation ng mga double bond carbons, it shows two possible structure. Okay? So ito yung carbon 1. Ito lang yung carbon 1, then carbon 2, 3, 4 and 5. That is still 2-pentene ha, 2-pentene. Okay, so for the first structure, um yung hydrogens are on the same side. And the priority groups same side din. Okay, so this shows a cis isomerism. This is particular a cis 2-pentene. Okay, for the second structure, tingnan yung um, same groups, yung hydrogen groups, even the priority groups are on the opposite side. So this shows a trans isomerism. Kapag tinanong kayo, ano yung priority group directly attached to this highlighted double bond carbon? Priority group here is an ethyl, diba? CH2, CH3, ethyl. On the other double bond carbon, the priority group attached to it is a methyl. Magka-opposite side yung priority groups, then that is a trans isomerism. Okay? So that is how to predict a cis trans isomerism. So I repeat, you have to check first if the molecule shows isomerism. So check nyo if the same number of carbon atoms, the same number of hydrogen atoms, or any uh, other atoms aside from hydrogen of carbon, if there is. So if you already check the isomerism, then identify the general class of isomerism. So let's say it shows geometric isomerism because the double bond carbons, each double bond carbons have different group of atoms attached to it, then that is geometric isomerism. For the specific type of isomerism, it is a cis trans isomerism. It shows a cis trans isomerism if the double bond carbons each has one hydrogen attached to it. If it does not follow what is the condition being set for a cis trans isomerism, then that cannot be a cis trans isomerism. Okay. So, for example, in this structure presented, you have a 2,3-dimethyl 2-butene. Okay, so you simply this is the name, has systematic name na, so no problem with the name of the alkene. But you have methyl at carbon 2, another methyl at carbon 3, so 2,3-dimethyl. Then the position of double bond is at carbon 2. Now, try to check if this molecule shows geometric isomerism. Does each double bond carbon have different group of atoms attached to each double bond carbon? Different ba? No. Kasi, if you try to check, this double bond carbon, yung naka-attach sa kanya, methyl, methyl, the same group. On the other double bond carbon, ganun din, the same group, methyl, methyl. Therefore, this does not show geometric isomerism. Okay? Another example. Okay, another example is the 2-methyl in the molecule 2-methyl 1-propene. Tingnan, yung carbon 1, yung naka-attach sa kanya, carbon 1, double bond. Okay, double bond carbon. Puro hydrogens. Okay. On the second carbon, or which is the double bond carbon, second double bond carbon, puro methyl. Okay. So this does not show geometric isomerism kasi nga the same group of atoms directly attached to each double bond carbon. Okay, so that does not show geometric isomerism. Yung criteria kasi natin for geometric isomerism, dapat on each double bond carbon again, on each double bond carbon, dapat magkaiba yung group of atoms directly attached to it. Okay? The same with the other group. Although sa first double bond carbon, okay naman, magkaiba yung group of atoms attached to it, but try to look at the second double bond carbon. Puro hydrogen. Okay, so again, it doesn't show geometric isomerism. And for the second, for the fourth structure, ganun din, no? On the first double bond carbon, magkaparehas lang yung group of atoms attached to the double bond carbon. So this again does not show geometric isomerism. Now what about in the molecule of 2-chloro-2-butene? Okay, 2-chloro-2-butene. So when you try to look at the directly bonded group of atoms for each double bond, okay, pasok siya sa criteria na geometric isomerism. Ano sabi natin kapag geometric isomerism? When we try to look at the attachments, no? Attachments group of atoms attached to the double bond carbon dapat magkaiba. So for this example, sa first double bond carbon merong chloro, merong methyl. So magkaiba yung group of atoms attached to that double bond carbon. On the second double bond carbon, magkaiba din yung group of atoms attached to it. You have a hydrogen and a methyl group. So pasok sa criteria na geometric isomerism. Now, another question, follow-up question, does it show a cis trans isomerism? Does it show a cis trans isomerism? Hindi. Diba? It does not show a cis trans isomerism knowing na sa double bond carbon na to, walang hydrogen atom directly attached. Again ha, walang hydrogen atom directly attached to the double bond carbon. Yung directly attached dito is a Cl, a chlorine. Sa baba is a carbon. Okay? Now, because of that, it cannot be predicted, okay? It cannot be represented in a cis-trans isomerism. Instead, this can be represented by another specific type of geometric isomerism. This can be represented by an EZ isomers. Now, what are these EZ isomers? Kailan natin masasabi na yung structure E isomer? Kailan naman siya Z isomer? So, balik ko na ko ha. If pasok siya, geometric isomerism din, pero when you try to check on the double bond carbon, walang hydrogen yung isa, okay? Either sa isa walang hydrogen, okay? Or yung dalawang double bond carbon talagang walang hydrogen atoms directly attached, then that is already a different representation of geometric isomerism. You can represent the structure by an easy isomers. So these are the basis for easy configuration that can include prelog sequence rule. So under this rule, okay, you have to consider each, no, para ma-identify nato sino yung E tapos Z na isomers. Consider each double bond carbon separately. So kapag syempre dali naman malocate ang carbon to carbon double bond, di ba? Now, try to consider this separately. Okay? Separate mo siya, then tingnan mo yung mga naka-directly attached sa kanila. Again, consider each double bond carbon separately. Again, look at the two atoms directly attached to each double bond carbon. So look at the two atoms directly attached to this double bond carbon. Okay? Then you have to rank them according to atomic number. Okay? Take note, An atom with a greater atomic number ranks higher, and that is considered a priority group. So let's say for example, yung kanina na last structure represented sa previous nga slide, 'di ba? That is 2-chloro 2 butene, 2-chloro 2 butene. Okay? Now, when you check the, 'di ba? We have to consider each double bond carbon separately. Consider natin, hindi natin siya ibe-break talaga, pero imagine you check this double bond carbon. Okay? So separate mo siya pag-check. Okay, individual. So for this double bond carbon, let's say, ako siya i-highlight o color black ha. For this double bond carbon, tingnan mo yung mga group of atoms directly attached to it. And then, i-rank mo yung atom directly attached to it based on their atomic number. So, yung directly attached sa kanya, we have chlorine, and on the other side, carbon. Okay? You have chlorine, sa baba, carbon. Again, we're talking about the atom, not the group of atom directly attached to it. The atom, yung mismong atom na naka-directly attached to this double bond carbon. I-rank mo based on atomic number. Sino yung mas may higher atomic number? Obviously, when we talk about atomic number, in a periodic table, kung periodic table to, um, going to the right and going down, increasing yung atomic number. 'Di ba? Kasi yung atoms in a periodic table, they are arranged according to atomic number. So, papalayo ka, going to the right, then going down, increasing yung atomic number. And chlorine po, ito yung may higher atomic number. So, this is of higher priority. Okay? Ito yung may higher atomic number. So, siya yung considered as priority group for this double bond carbon. Now, in this double bond carbon naman, check mo separately, di ba? Check mo separately yung mga double bond carbon, yung mga atoms directly attached to it. Merong hydrogen, then sa baba, you have carbon atom. And we all know already na hydrogen is not a priority group. Di ba? Pag sinabing priority group, any group except hydrogen. Therefore, automatic, ito yung may higher rank, 'di ba? Based on atomic number, yung carbon. Yung carbon dito directly attached to the double bond carbon. So you already rank the atoms, no? The surrounding atoms directly attached to the double bond, to each double bond carbon. Okay? Now, kailan natin masasabi na E then Z isomers? If, okay, di ba? Gi-highlight na ko ang higher for the first structure. For the first structure, structure 1, yung priority groups are on the opposite side, then that is regarded as E isomer. Again, if two priority groups, okay, if the two priority groups are on the opposite side, then that is regarded or represented as E isomer. Saan ba galing yung E isomer? That comes from the German word Entgegen. Okay, Entgegen. This is a German word. Ibig sabihin ng Entgegen, opposite. Okay, opposite. So, para madali lang, no, madali lang siya madumduman nga, okay, E isomer, opposite side yung priority group. You pronounce opposite as epicet. Okay, so medyo paslang ka, epicet. Pwede ra ihapon, epicet. Or pwede ra sad epicet. Okay? So, para dili malimtan. So, yan yung ginagawa ko kapag ga-memorize ko og geometric isomerism. Kapag E-isomer, the priority groups are in opposite sides. Okay? Now, kapag naman Z-isomer, the two priority groups are on the same side. So, para dali lang gihapon madumduman, Z-isomer, same side, you pronounce same as same. Then side, ana. Okay? So, same side. Same side, Z-isomer. Okay? So, balik ko na to. Kailan ulit, uh, kailan ulit yung structures be represented in E or Z isomerism kapag on each double bond carbon, yung isang double bond carbon pala walang hydrogen, or yung dalawang double bond carbon walang hydrogen attached to it. Okay, then that can be represented in an E or Z isomerism. E isomer if the two priority groups are on the same side. Okay, so for the second structure, siya yung Z isomer. For the first structure, siya yung E isomer. So that is how to write the full name of alkene. Okay? Yung letter E, capital letter E, capital letter E, um, it is written or enclosed in a parenthesis. Okay, capital letter E is enclosed in a parenthesis, then dash 2-chloro-2-butene. Okay, next, let's have another example. Okay, for this example, as you can see, dalawa yung double bonds, okay, in this alkene group. Okay, so analyze first which part of these molecule, saang parte na may double bond shows geometric isomerism. Saang parte ng molecule na to shows geometric isomerism. Sabi natin, kapag geometric isomerism, dapat for each double bond carbon, magkaiba yung group of atoms attached to it. That's the time it shows geometric isomerism. Well, in this example, okay, itong highlighted ko with color black, let's say, color red na lang. Itong highlighted with color red, that part of the molecule do not show geometric isomerism. Diba? Tingnan mo yung carbon 1 in this molecule, which carries a double bond. Diba? Yung directly attached to it are hydrogens. No? The same atoms attached to this double bond carbon. So this does not show. In this part, it does not show geometric isomerism. So ito yung may geometric isomerism. Okay? Yung mas naka-highlighted in a trigonal planar orientation. Okay? For this carbon, magkaiba yung directly attached sa kanya. Ito din, magkaiba yung group directly attached sa kanya. Now, try to check. Sabi dito, I'm sorry. Now, if we try to check the EZ isomerism, again, EZ isomerism, the priority group are on the opposite side. Asan ba yung priority group? Okay, sige, ato siyang step by step ha para masabtan. Sabi natin, to identify if this is an E or Z configuration, consider the double bond carbon separately. Then check H. Check mo yung double bond carbon on the left side. Ano yung mga naka-attach sa kanya? Directly attached sa kanya, carbon. Okay? Di ba kapag CH3 ang naka-attach dyan directly is a carbon. Then terminal group yung tatlong hydrogen. Okay? So carbon directly attached sa kanya, sa baba hydrogen. So this is the priority group nasa taas. On the second double bond carbon, yung nasa kanan na double bond carbon, ang directly attached sa kanya, we have hydrogen on top. Then nasa baba is the priority group kasi this is carbon. It has higher atomic number compared to hydrogen. Again, carbon has higher atomic number than hydrogen. So siya yung higher rank here based on atomic number. So the priority groups priority groups are on the opposite side. So this molecule of 3-methyl 1,3-pentadiene is in opposite, no, E isomer. Yeah, let's have another example. A skeletal structure of an enol. This is an enol. So never mind the naming ha, because we have a separate segment how to name alcohol with a double bond. Okay. So focus natin ngayon is the identification of the specific type of geometric isomerism. Okay. So go directly with the double bond carbons. Double bond carbons. Consider that separately. Okay, consider that separately. So nasa taas, for this double bond carbon, yung nasa taas is a methyl group. So we have a carbon directly attached to the double bond carbon, and then we also have a chloro group. So between carbon and chlorine, higher priority group, higher rank based on atomic number is chlorine. Okay? And then for the second double bond carbon, okay, yung nasa taas, 'di ba? This is a carbon. Plus it is bonded pa gyud with an oxygen. Then yung imaginary dyan, yung nasa baba, imaginary kasi skeletal structure to, 'di ba? Don't forget kapag skeletal structure, usually imaginary yung hydrogen. So directly attached to it, another group of atom is hydrogen. And we all know hydrogen is not a priority group. So ito, yung priority group nasa taas, 'di ba? That is on top of this double bond carbon. So opposite ulit, no? Opposite side. So this is regarded as E isomer. Another example, this is another enol. So separate mo ulit when you check. Okay? Separate mo when you check. You don't really break good nga ibulag nimo ang double bond carbon. So i-check lang nimo siya separately. So for this carbon, ano yung directly attached sa kanya? You have a hydrogen sa baba, sa taas, a methyl group. Okay? So yung priority group nasa taas. Kasi carbon is directly attached to that, to the double bond carbon. Okay? Now, on the other side, yung nasa kanan, no? Nasa right na double bond carbon, the directly attached atoms, again, we're talking about the directly attached atom. Directly attached atom here is oxygen, nasa taas. Nasa baba is carbon. So, between oxygen and carbon, sino yung much may higher atomic number, di ba? That is oxygen. So, same side yung priority groups. Then, that is regarded as Z isomer, same side. Okay? And lastly, okay, this is just the same compound, no? 2-butene 1-ol pa rin. But this time, this is in E isomer. Okay? Kasi ulit, yung OH na this time, yung OH na this time for this double bond carbon nasa baba. To opposite side na yung priority groups. Opposite side na yung priority groups. So, E isomer. Now, balik tayo sa structure 1. Sa structure 1, yung directly attached sa kanya, directly attached to each double bond carbon, di ba? Each has a hydrogen. Each has a hydrogen. That is why, kapag tinanong kayo, possible ba yung cis trans isomer for this structure? Yes. Okay, possible din. Okay? Possible din yung cis trans isomerism for this structure. Kasi nga, sabi natin, cis trans isomer that exists if in each double bond carbon may tig-iisang hydrogen directly attached to it. Okay, let's have the sample problem. I will try sample number 4. I will only try sample number 4. The rest, you answer this. Okay, you fill in your answer in the given Google form. Okay, in the posted Google form in your Google Classroom. All right, so that will serve as your assignment 2. Okay, let's have number 4. Okay. Sabi sa question, which of the following compounds can exist as pairs of cis trans isomer? So you have to check first if saang molecule dito ng alkene can exist in a cis trans isomer. Okay? Then that's the time you draw the cis trans pairs. Okay, for molecule number 4, go directly with the double bond carbons. Double bond carbons. Then try to check. Try to check if each double bond carbon may naka-attach na hydrogen. 'Di ba yan yung pinaka goal natin, pinaka criteria natin for it to be regarded as cis trans isomerism. So for each double bond carbon, walang hydrogen directly attached to each double bond carbon, 'di ba? Kasi check natin ha. Ito um yung encircle with color red, ito 'yon. Okay, yung directly attached sa kanya, sabi diyan, dalawang methyl group. Dalawang methyl group. So walang hydrogen. On the second double bond carbon, ang naka-attach sa kanya, we have naka-parenthesis, 'di ba? Yung naka-parenthesis, you have a methyl and you have an ethyl here. So walang hydrogen. Therefore, for number 4 na structure, it cannot be represented in a cis trans isomerism. So the rest, you try to check, okay, you try to check if which of the following which of the following isomers exist as pairs of cis trans isomer. For the drawing, you can just draw it in your notes. Okay? You can just draw it in your notes. Okay? Next, for this example, I will answer the item number 3. So, okay, let me answer item number 3. Then again, the rest of the items, you fill in your answer in the provided Google form. Okay. So, according to the statement, the instruction, assign E or Z isomer to the following alkenes. So, you just, no need to name the alkene. You simply assign if it is an E isomer or a Z isomer. So, yun lang. So, for number 3, I will go directly with the double bond carbons. I will check the double bond carbons separately and then look at those atoms directly attached to each double bond carbon. So for this double bond carbon on the left side, directly attached sa kanya, we have a carbon. Ganon din, carbon. So if that is the case, the same atom is directly attached to that particular double bond carbon, then proceed on the next. You proceed on the next atom directly attached to these first attachments. Okay, so proceed ko sa next. I have here a carbon ulit. Dito, carbon ulit. Tama? So, the same pa rin. The same pa rin, carbon, carbon. Then, you proceed. You proceed. Sa top, yung nasa top, you have a methyl. Dito, you have an imaginary hydrogen na. Imaginary hydrogen. But yung nasa taas, encircled with color green, may carbon ka pa. Therefore, the group na may higher rank is ito. Okay? Whereas on the second double bond carbon, ba? Ganun din, the same. Yung first atom directly attached to the double bond carbon, yung nasa kanan ha, itong nasa kanan na tayo. Itong nasa kanan na double bond carbon, directly attached sa kanya na atom, yung una is a carbon. So, proceed ka sa next. Okay? I-neglect mo na yung hydrogen kasi those are not priority groups. Hydrogens are not priority groups. So, yung next, you have an oxygen. Sabi dito, dalawang oxygen. Ang next na priority atom dito is also oxygen. Again, neglect the hydrogens. Hydrogens
these are not priority groups. Kasi 1 lang 'di ba yung atomic number ng hydrogen kaya hindi siya priority group. So dito oxygen din but isa lang. So sino yung much may higher atomic number? Syempre yung may dalawang oxygen. So higher group nasa taas. Okay? So if both priority groups, okay, both priority groups are on the same side, 'di ba? Same side, nasa taas. Same side. So this is regarded as Z isomer. Okay, so for the rest of the items, it is already your responsibility to fill in your answer in the posted Google form. Now, still talking about geometric isomerism, aside from it occurs among alkenes, it may also occur among cyclic compounds, but these are very rare. Okay, not common siya, but it may occur among cyclic compounds, particularly cycloalkanes. Okay, it occurs among cycloalkanes. So cyclic compounds ng alkane. Carbon to carbon single bond in a cyclic chain. So say for example, if you try to look at the three-dimensional structure of this cyclic compound, and then you try uh, to look at the structure on a side view, you can see here that the substituents on the cyclic compound sa first structure, structure 1, the cyclic compounds on structure 1, same side yung priority group, 'di ba, nasa baba. Kung imong lantawon ba ang plane, ang cyclopentane sa iyang side view. So, side view nimo kana nga orientation sa iyang side view, nasa ubos sa plane ang mga methyl, nasa taas sa plane ang mga hydrogens. So same side ang hydrogen atom, same side ang methyl groups. This shows cis trans isomerism, 'di ba? So what specific type of geometric isomerism? This is a cis, no? Cis isomerism. Kaya yung name niya, cis 1,2 dimethylcyclopentane. Okay? By the way, when the geometric isomerism occurs among cyclic compounds, the only specific type of geometric isomerism that occurs with them is a cis trans. Okay, cis trans. Cis trans lang. Sige. On the second structure, tingnan mo yung nasaan yung hydrogen, 'di ba? Opposite side. Yung isang hydrogen nasa taas, yung isang hydrogen nasa baba. Okay? So, trans naman ito. Trans 1,2-dimethyl-cyclopentane. Okay, another example, sa di-substituted na hexane. So we have a cyclohexane. The priority groups are on the opposite side, 'di ba? Yung bromine dito nasa taas, yung bromine naman nasa baba, yung isang bromine nasa baba. So opposite side yung substituent sa cyclohexane. So that shows trans isomerism. Then the other one is on a cis isomerism kasi same side yung priority group, same side yung hydrogens. Okay? Okay, another example. Ito naman on the top view. Okay? Tingnan mo yung molecule. Tingnan mo yung molecule on top of the plane. Again, tingnan mo yung molecule on top of it. On top of the molecule, di ba, may mga substituents. You have two methyls. Okay, sa carbon 1 and sa carbon 2, each has methyl. So this is named as 1,2-dimethyl-cyclopentane. Now, question. In these structures, sino dito ang cis, sino yung trans? Na take note. On a top view, kapag dinraw yung three-dimensional orientation ng mga substituted atoms, a dashed line is usually used. This is to represent those group of atom or atom below the plane. Okay, kapag dashed, Okay? Kung naka-dashed ba na. Kapag naka-dashed ang line, this bond is simply to show the group of atoms or atom below the plane. So kung naka-top view ka, imo lang tawad ang plane on a top, no? Top view niya, kanang dashed meaning ana nasa ubos sa plane ang substituent. So nasa ubos ang methyl kung naka-dashed. Okay? Kapag naman solid, so example kani, this is a solid line, di ba? So in a three-dimensional orientation, solid line represents group of atoms above the plane naman. Above the plane. So kung top view kanang nakaturo sa imo, so nakaturo sa imo solid line. Okay? So nasa top, nasa above ng plane. Okay? So in this case, the first structure here, since nasa baba yung dalawang methyl, so same side, 'di ba? Nasa baba yung dalawang methyl, same side, so cis. Then the other one is a trans. Kasi opposite side. Yung isa, isang methyl nasa baba ng plane, yung isang methyl group nasa nakaturo sa iyo, so um opposite side. Then for these second structures, yung first structure naman dito sa 1,4-dibromocyclohexane, ito yung trans. Okay, kasi yung bromine, isang bromine, yung nasa kaliwa, nakaturo sa iyo, 'di ba? Nasa taas ng plane. Okay, if you try to look at the cyclic compound on top view, nakaturo sa iyo yung isang bromine, nasa baba naman yung isang bromine, so opposite side. Then the second structure, ito naman yung naka-cis isomer. Kasi nakaturo sa yung dalawang bromine on top of the plane.